Hello, this is Dr. Brown. In this short video, we're going to answer a question that a student asked about how to find oblique asymptotes of a rational function. And we're going to work 3 or 4 examples here. You may recall that if you have a rational function, which is a ratio of 2 polynomials, that if the order of the numerator is equal to 1 plus the order of the denominator, then you have a slant asymptote that will have an equation y equal sum mx plus b. This is the equation of a straight line. That would be its asymptote. And the question was, how do you find that? And what you do is you do polynomial long division. In other words, you take the numerator and divide it by the denominator. So we're going to do, first of all, an example here. The numerator is x plus 3. The denominator is x squared minus 6x minus 1. By the way, if there had been no minus 6x here, we would have had to have put 0 where the 6 is, because we have to fill in all the places for the x squared, for the x, and for the constant term. Now we're going to do a long division. So we start out by taking the x and dividing it into x squared, and we get x. Now, just like you do in regular long division, you multiply this by the divisor, and we get x squared plus 3x. Now, just as we do in long division, which I guess a lot of us don't do anymore because we have a calculator, we subtract. So we take this and subtract off this. So x squared minus x squared is 0, minus 6x minus 3x is minus 9x. And then we bring down to minus 1. Now we take x and divide it into minus 9x, and we get minus 9. And now we multiply minus 9x, minus 9 times x is minus 9x, and minus 9 times 3 is minus 27. Now subtract, and we get minus 9x minus minus 9x is 0. Minus 1 minus minus 27 is plus 26. This is the remainder, but notice we have the oblique asymptote, which will be y equal x minus 9. Let's do another one. Another rational function. Notice that the degree of the numerator is 3, the degree of the denominator is 2, so we know we'll have a slant asymptote. So let's do the long division. X squared plus 8x plus 15, all divided into 2x cubed plus 15x squared plus 22x minus 11. Now do the long division. X squared into 2x cubed gives you 2x. Multiply 2x times all of these terms, and you get 2x cubed plus 16x squared. 15 times 2x is 30x. Now subtract, and we get 2x cubed minus 2x cubed is 0. 15x squared minus 16x squared is minus x squared. 22x minus 30x is minus 8x. And bring down your minus 11. And now x squared goes into minus x squared minus 1 times. Minus 1 times x squared is minus x squared. Minus 1 times 8x is minus 8x. Minus 1 times 15 is minus 15. And notice when we subtract, we get 4, which is a remainder. But what's important is the long division, which gives us y equals 2x minus 1 as the oblique asymptote. Now, here's another example. Notice the degree of the numerator is 2. The degree of the denominator the degree of the denominator is 2. The degree of the numerator is 3, so it has a slant asymptote. Here we have to be careful and write minus x squared first, plus 3, divided into 2x cubed, plus 4x squared. Notice we don't have any x terms, so we're going to put 0x minus 9. And minus x squared goes into 2x cubed minus 2x times. Minus 2x times minus x squared is 2x cubed. 3 times minus 2x is minus 6x. Subtracting, notice we had 0 x squared here, so subtracting we get 4x squared. Subtracting here we get 6x. Bring down your minus 9. And now minus x squared into 4x squared is minus 4. So minus 4 times minus x squared is 4x squared. 3 times minus 4 is minus 12. We get 0, 6x, plus 3. And this is our remainder. But notice the oblique asymptote is minus 2x minus 4.